Hey there guys, in this video we're going to take a look at the last lesson for our exponents unit, looking at rules for exponents and radicals. This is kind of like everything all mixed together in one unit. So looking at the review of what we've talked about so far through this whole unit, we've got our rules for exponents that they have listed for us right there. So if you look, they kind of remind us that if we have two of the same bases that are being multiplied together, we can take those exponents and add them together. And if we have a base that's inside of a set of parentheses, we can take the exponent and distribute it or multiply it times those two exponents together. If we've got two bases that are being multiplied, and they have to be multiplied, there can't be add or subtract in there with it. If they're being multiplied, you can take that exponent and distribute into the exponents that are inside those parentheses. Each of those numbers or variables is going to have the exponent distributed to it. If we've got two bases that are the same being divided by each other, we can take those exponents and subtract them. And then if we have two bases being divided inside of the set of parentheses, we can take that exponent that's on the outside and distribute it to the exponents that are on the inside. Also, a friendly reminder that anything to the 0th power is going to be equal to 1. It doesn't matter how small it is or how big and complicated it is. 1a, b. If what's on the outside is a 0, this whole thing, you don't need to do any simplifying on the inside. This whole thing is going to be equal to 1. And it works the other way too. So like if you've got 1 over a to the negative n, because they do a really good job of showing you here, a to the negative n is going to want to go to the other side of the fraction. So it'll move to the bottom. With this one, if it starts on the bottom, it wants to move to the front. And you kind of use this as an operation to move it. So once you move it, it's not going to be negative anymore. And this is just a review of what we covered in class. Okay, so let's start trying out these problems and see how Edmentum shows you how to do these. So looking at the first type of practice problem, with these, the very first thing that I will do is I will make sure I simplify everything on the numerator or on top of the fraction, and then everything on the bottom or in the denominator of the fraction. So if I'm looking, there aren't any other numbers that I can multiply the 22. There's only one a variable and one b variable in the numerator in the top. And so then I'll go through and do the same thing for the bottom. So 4 and then the a and then the b. There's only one of each. So there isn't any simplifying to do in the numerator or the denominator. So now I'm going to start simplifying between the numerator and the denominator. So I'm going to focus on things that are alike. So I'm going to focus on the 20 and the 40, the 20 and the 4, and then just divide those two. 20 divided by 4 is going to be 5. And then I'm going to go through and I'm going to focus on just the a's. And that way we're not trying to have to worry about everything all at once. We're just focusing on the little pieces and using the rules that we know to simplify those little pieces. So here I have a divided by a to the 5th. Remember, whenever you're looking at variables, just like it's kind of understood that we have a 1 in front of an a, it's also understood that for an exponent, if there isn't one written, it has a value of 1. So this is 1a to the 1st power. So because those two bases are being divided, we can take those exponents and subtract them. So I've got a to the 1 minus 5. And then just go ahead and plug that in your calculator real quick. There's no sense in getting these wrong and then accidentally having a negative somewhere where it shouldn't be or missing a negative where you need it. So if I simplify, I'm bringing down the 5 that I had above. A to the 1 minus 5 is going to give me a to the negative 4. And then looking at the b's, because the a's are done, looking at the b's, we're going to have b to the 2nd divided by b to the 9th, or b to the 2 minus 9. Double check it in your calculator. B to the 2 minus 9 is going to be a negative 7. So looking at this answer or looking at this, what we have written here, we need to double check and say, hey, is this a good answer? Because remember, there's a couple things we can't have in an answer. We can't have more than one of the same variable. So this is my potential answer right here. There's only one A, there's only one B. Whereas before, when we did this problem, there were two A's and two B's. We simplified it down to the point where there's only one of each variable. Then we need to check and see, do I have any zero exponents? So looking, we don't have any zero exponents that need taken care of. And then do we have any negative exponents? And if there are negative exponents, those need to be simplified. So here I have a to the negative fourth, b to the negative 7. I need to take this and make this be a fraction. That way I can move those variables with those negative exponents down to the bottom. So if I do that, the 5 is not going to move because it does not have a negative exponent. So it's going to stay in our numerator. So I've got 5 divided by a to the fourth, b to the b to the positive 7th, because we use that negative to move it to the other side. So if I'm going to go and I'm going to type that in, I'll type 1 in with you and then let you do the others on your own. But if I type 1 in, I'm going to go ahead and start out and say I have a fraction. My numerator is going to be 5, and then click on the bottom or push the down arrow to get to the bottom, a to the fourth, b to the 7th. So I've got, I'm going to do a lowercase just in case it's picky, a, and then I'm going to hit the to the button there, fourth, and then hit over so that it doesn't leave it as an exponent, lowercase b to the 7th. And there we go. All right. So I'll solve another one with you, but I won't type it in. I'll let you type it in. Looking at the next one that they give us, again, I check my numerator and just look at the top. There's nothing I need to simplify there. Looking at the denominator, there's nothing I need to simplify there. So I'm going to start simplifying top to bottom and matching up the things that are the same. So 6 and 3 are the same. They're numbers, and I'm not going to worry about any other variables with it. So I've got 6 divided by a negative 3 is going to give me a negative 2. And then I'm going to do the A's next because I've got those numbers taken care of. So I've got a to the negative 5th divided by a to the 9th, or a to the negative 5 minus 9, so a to the negative 14th. And then I'm going to simplify those b's. Looking at the b's, I've got b divided by b, which is just going to have a value of 1. So you can put the times 1 or you can not worry about it. So if I go through and I double check my answer to look and see if it's a good answer, the negative 2 is okay. The a to the negative 14 is not okay. It needs to go to the other side of that fraction. So negative 2 divided by a to the positive 14th times 1. That will leave your answer as negative 2 divided by a to the 14th. Okay, looking at this next problem, I'm kind of going to do the same thing that I did before. I know they have the fractional exponents there, but I'm not going to worry about it. I'm going to go through, to start with, I'm going to go through and simplify everything here. That's kind of what they're doing with the parentheses. They're telling you to simplify everything in there first and then worry about the to the 1/2 later. So if I focus on my A's, I've got a to the negative 2 divided by a to the negative 6. Or if I write it out exactly what's going on, I've got a to the negative 2 minus a negative 6. So if you put that in your calculator real quick, negative 2 minus a negative 6, that's going to give us a positive 4. So I've got a to the positive 4th, and then I'm going to do the b value next. I've got b to the negative 6 minus negative 2. So put that in your calculator really quick to check it. B to the negative 6 minus negative 2. And that's going to give us a b to the negative 4. And then that's going to be in parentheses. Don't forget your to the negative 1/2. So at this point, I'm going to go ahead and distribute. I'm going to go ahead and distribute the 1/2. So if I distribute that 1/2, I'm using that rule where I distribute this exponent to both of the exponents on the inside. So 4 times 1/2 is going to give us a squared. B to the -4 times 1/2 is going to give us -2. So looking at the possible answer that I have right there, it's not going to be a good answer because this should be a B. I have a negative exponent there. So to simplify it and make it be a good answer, the a squared would stay in the numerator because its exponent is positive. So I've got a squared divided by b, and since I've moved the b down to the denominator, it becomes a positive 2. So a squared divided by b squared is going to be the answer for that one. Looking at the next one. Same idea as the last one. Let me see if I can get something else other than a 1/2. There we go. There's a 1/3. Okay, so looking at this one, it's going to be the same exact idea that I did before. I am going to focus on just what is inside those parentheses and simplify what is inside the parentheses first, and then worry about distributing the 1/3. You can do it the other way. It's going to be a little bit more work, but in the end, just whatever gets you there that you understand works fine. But I'm going to simplify these guys first. That way I've got less variables to distribute the 1/3 to. So I've got x to the 3rd minus a -6, which is going to give me x to the 9th. And then if I focus on just the y's, I'm going to have y to the 9th minus a -9. So that's going to give me a y plus a positive if I switch it. So y to the 18th power and don't forget this, don't forget about the to the 1/3. So now that I've simplified everything inside the parentheses and both of my exponents are positive exponents, I can take that 1/3 and distribute it to both of those exponents there. So I've got x to the 9 times 1/3 and then y to the 18 times 1/3. So you can put those in your calculator and simplify them. It's effectively 9 divided by 3. So that'll give us x to the 3rd, y to the 18 divided by 3 is 6. So that's going to be our answer. I double check and make sure that I only have one of each variable. And then I double check my exponents and make sure that they're positive and not 0. And so then that will make it a good answer for this problem. All right, looking at the last problem type that they could give you to work with. No, this is the second last one. Sorry, my bad. Looking at this one, they kind of divide up the problem a different way. Looking at the one before, they had everything on the inside of the parentheses, and so we worked inside the parentheses to simplify there. With this one, they kind of switch it up a little bit. They set the parentheses here in the numerator and then here in the denominator. So because they've split up the parentheses between the top and the bottom, we've got to take care of those first before we can start dividing top to bottom. So for this one, I'm going to distribute that 4. Don't forget to distribute it to the y. Remember that y variable has an exponent of 1. So I'm going to do x to the 3 times 4 is going to give me x to the 12th. And then y to the 1st times 4 is going to give us y to the 4th. And then z to the 2 times 4 is going to give us z to the 8th. Divided by, and then I'm going to do the same thing for the denominator. I'm going to distribute that exponent of 2 to everything inside the parentheses, all the exponents in the parentheses there. So x to the -2 times 2 is going to be x to the -4th, y to the -2nd, and then z to the -4 times 2 is going to be z to the -8th. So at this point, there's a couple different ways that you could go about simplifying this. You could go ahead and move all of these variables up to the numerator and then worry about simplifying them from there. Or you could just simplify them where they are right now, meaning that you could just do x to the 12th divided by x to the negative 4, or 12 minus a negative 4, which will give you x to the 16th. And then do the same thing here, a 4 minus a negative 2, or y to the 6th. And then z, careful with this one. And this is why it's so important. And this is why I take the time to write these down, because a lot of people I feel like would look at this and want to make it z to the 0, but it's not, because it's going to be z to the 8 minus a negative 8, which is going to be z to the 16th power. So be careful with those. It just takes a couple extra seconds to write those things down, and then you'll get the problems right and won't have to worry about looking and doing more problems in the long run. So if we look at our answers, I've got one of each variable type. All of my exponents are positive and none of them are 0. All right, so let's take a look at the next one. This one's looking at this one, kind of the same idea as before. They've got us distributing negative exponents. So let's work through this one and see what happens. Feel free, whenever we do these, to go ahead and solve them out on a sheet of paper on your own before I work my way through them and see if your answer matches my answer by the end. All right, so if we take a look at this guy, this is another, we have to simplify everything on the top and distribute that negative 1, and everything on the bottom and distribute the negative 1 before we can start mixing our numerators to denominators. And it's because of these parentheses. These parentheses are what makes it work just a little bit differently than our other problems. And that's okay. We just solve it a different way than we did the other ones. Still using all the same rules though. So I'm going to go through and I'm going to distribute that negative 1 to everything in the numerator. So I've got x negative 2 times a negative 1 is going to be a positive 2. Y to the negative 3 times a negative 1 is going to be a y to the 3rd. And negative 4 times the negative 1 is going to be a z to the 4th. Divided by, I'm going to do the same thing in my denominator. X to the negative 5 times the negative 1 is going to be a x to the 5th. Don't forget this y has an exponent of 1. So y to the 1st times the negative 1 is going to be y to the negative 1, z to the positive 5, because negative 5 times the negative 1 is going to be a positive 5. So then I'm going to go through and I'm going to simplify numerators to denominators. So here I've got 2 minus 5. So I'm going to have x to the negative 3. Looking at the next one, I've got 3 minus a negative 1. So it's the same thing as 3 plus 1. So y to the 4th. And then 4 minus 5 is going to give me a y to the negative 1. Or sorry, a z to the negative 1. So looking at the answer to double check and make sure everything's okay, I'm going to have, I've got one of each variable, which is great, but if I check my exponents, I've got 2 of them that are negative and need to be moved to the other side of the fraction. So if I do that, I've got y to the 4th divided by x to the 3rd, and you can put z to the 1st or just z. Either way will work just fine. So those of you who worked ahead, how'd you do? If you missed it, go back and work through and see if you can find your mistake. All right, looking at the last problem, or the next problem that they gave us here, I think it's the last one. I'm at least problem type wise, and I'll see if I can't do two of these with you. So looking at these, they're having us use the power rule here. They're going to want us to distribute, and this is different because now we've got, instead of just having like a 1/2 or a 1/3 to work with, they're giving us a 2/3. So what I'm going to do is I'm going to use the rules just like we did before. With these, we need to simplify everything numerator first, everything denominator first, distributing those exponents before we can simplify top to bottom. So if I do that, I'm going to end up with a to the 2/3. I don't need the parentheses there. So a to the 2/3, b to the 2/3. Because remember, they both have that exponent of 1. Divided by a to the negative 1/3, b to the negative 1/3. And then looking at this can't be a good answer because I've got 2 a's in my problem, 2 b's in my problem, and I can only have one of each variable type. So if I look to simplify right here, I've got a divided by a. I've got 2 of the same bases, so we're still going to subtract those exponents. So I'm going to have a to the 2/3 minus 1/3. So if I do that, that is, minus a negative 1/3. So 2/3 minus a negative is the same thing as plus. 2/3 plus 1/3 is going to be a to the 3/3. Looking at our b's, got the same thing going on with our b's. We've got a 2/3 minus a negative 1/3. So minus a negative, same thing as plus. I'm going to have b to the 3/3. So looking at my answer to double check and see if this is a good answer, now I have one of each variable, which is what we need to have. But if I check my exponents, they can be simplified. 3/3 can be simplified to 1. So I can just write this as, and both of them simplify to 1, a to the first, b to the first, or I can just write it as ab and have that be the final answer. All right, let's see if they give us one more problem. If not, well, I'll make it give us one more. Okay, there we go. This is another fraction one. Ooh, but this will still be a good one. We'll make this one our last one. All right, so looking at this one, we've got 9a to the 5th, b to the 5th to the 1/2 divided by ab, whole thing to the negative 1/2 power. So I'm going to do the same thing that I did before. I'm going to be distributing the 1/2. So I'm going to have 9 to the 1/2, b to the 5 times 1/2, and then, that should be an a. So a to the 5 times 1/2, and then b to the 5 times 1/2, divided by a to the negative 1/2, b to the negative 1/2. So if you put 9 to the 1/2 power in your calculator, if you put this guy right here, that guy right there, if you put him in your calculator, he should simplify and tell you 3. Pretty much when you've got fractional exponents with whole numbers, that tells you what this number, the denominator, tells you what root you're taking. So that tells us we're taking, since it's a 2, we're taking the square root of 9. If it had been 3, we would be taking the cube root of 9 and that kind of a thing. So here I'm going to simplify these guys first. And I'm going to leave them as fractions and not decimals. It's just my preference. You could probably do it either way, but I want to leave it as fractions. So I'm going to have a to the 5/2, b to the 5/2 divided by, and the denominator is not going to change, a to the negative 1/2, b to the negative 1/2. So if I look and I start trying to see, hey, am I done? Do I have a final answer? I've only got one number, which is what I'm looking for, but I've got 2 A's and 2 B's. So I need to simplify to get those to be gone. So I've got a to the 5/2 divided by a to the negative 1/2. So here I'm going to do 5/2 minus a negative 1/2. And that's going to give us 3 times a. 5/2 plus 1/2 is going to give us 6/2. And then looking at that next part, I've got b to the 1/2. So 1/2 minus a negative 1/2. This is another one you've got to be careful with because I think a lot of people would want it to be 0, and it ends up being b to the 2/2. So our answer is looking better. We're looking at, we've only got one number. We only have one of each variable, but those exponents still need to be simplified. So if I do that, I keep the 3. It doesn't need simplified. A to the 6 divided by 2 is 3. B to the 2 divided by 2 is 1, or just to the B. Or sorry, just times B. So 3A to the third power times B is our answer for that one. All right, so I think that's all there is for those. If you've got any questions, feel free to email me, let me know. You could also drop in during my virtual office hours and ask me questions then, and the office hours are available on the spreadsheet. Take care, guys.